So, well, just fortunately everybody's here, right? So, okay. So here, substitution effect, the price of X decreases, so I'm buying X2 instead of X1. Now, to isolate the substitution effect, what I want to do is I want to take money away from this person, right? So I want a parallel shift in their budget line down to where it's just tangent to the old indifference curve, where he's just as well off as he was before. So I have the parallel shift, and now he consumes X3. The difference between X1 and X3 is the substitution effect. It's solely because the price changed. And of course, the rest of the difference between where he ended up, right, up here, and X3 is the income effect. He consumes more of X because he's richer, right? So I keep the same slope, right, as a parallel shift. I take income away from her to make her just as well off as she was before. She chooses X3. In this case, the substitution effect is negative, and it's always negative. And here, the income effect is positive. Okay. So substitution effect's always negative, as I said. The partial of X, the compensated X, right? In other words, compensated is I take money or I give him money to make him just as well off as he was before. With respect to the price is negative. Well, in this case, the income effect is positive because it's a normal good. It's just a partial of X with respect to BX, but that goes through income. So I have basically a chain rule. The partial of X with respect to I times the partial of I with respect to PX. In this case, is positive. Okay. Thank you. Perfect. Okay. So here, the same exercise we just went through. I start at point A, consuming. The price of X decreases, right? And I go to point C. I take money away from this person, right? And I put him on the old indifference curve at point B. The difference between what he was consuming here and here is the substitution effect. In this case, right, when I add the income effect, he actually buys less X. That means that the income effect for this good is negative, which means it's an inferior good. In other words, when I get richer, I buy less of this stuff. Questions? But it's the same process as we just went through before. Which brings me to what we call the Slutsky equation. Right? Here I have what I call a compensated demand curve, H of X. It's no longer a Marshallian demand curve. In that I want to keep utility constant, or I want to compensate him to keep utility constant. That means in these examples I gave you, we're taking money away from them. If it was a price increase, we'd give them money. We'd shift the, excuse me, we'd shift the budget line up with the new prices. So what I want is a partial of this compensated demand curve, our Slutsky equation, with respect to X, right? Where H of X is a function of the prices, PX and PY, utility, and the demand for some other good, in this case, the other good as well. But most Marshallian demand curves that aren't Cobb-Douglas, right, are going to have Y in, excuse me, in the Marshallian demand, because other goods affect, right? So here our expenditure function, to do the derivative of the Slutsky equation, I need to explain first the notion of the expenditure function, which we already derived mathematically. The arguments of the expenditure functions are price, the two goods, right? The price of the two goods and the utility level. So the expenditure function tells me the minimum expenditure, the minimum amount that I have to spend in order to achieve a given utility. With the prices given as PX and PY. In that last figure, we can start by considering the budget set. The slope of the budget set is determined by the ratio of prices, and we know that. And the income tells you how far, right? How far the budget set goes. In other words, what's the highest indifference curve I can reach? To define the demand, we find the point where the indifference curve is tangent to the budget line, like we did before, right? So there it is. We have all those budget sets. That's the minimum amount that I have to spend to get to this indifference curve that gives me a set level of utility. Right? Or I can start with the given level of utility and prices without knowing the income level, right? The budget line that is tangent to the indifference curve has a property that represents the cheapest amount. In other words, moving my income down until I get to that point where I spend the least to get that amount. That represents the cheapest amount of expenditure needed to achieve a given level of utility. So I can think about having a fixed budget and choosing the consumption point that maximizes utility, as we've been doing. We know that the tangency point has a property that marginal rate of substitution equals the ratio of prices. We probably said that probably 24 times already. So I can look from the opposite direction. With a utility level fixed, I can try to achieve the cheapest income that will allow me to achieve that utility. And I find the same conditions. I want to find the income level so that the budget set is tangent to the indifference curve. At the tangency point, the MRS, the marginal rate of substitution, is equal to the ratio of prices. In other words, now I'm just doing it backwards. Instead of moving up to the highest indifference curve that I can find that goes to the budget set, I pick a fixed indifference curve, and I find the minimum income that will get me to that indifference curve. In the end, it's the same. It's just, in the end, it's the same. It's just a process. Instead of going up to different indifference curves to getting to the highest indifference curve, I do the opposite. I have a fixed indifference curve, and I figure out what income that I have, the least income that I have to spend to get me to that. So, efectivamente es lo mismo. Where we get to is exactly the same. But it's a way of thinking of it. The way we're doing it is because we're doing that substitution effect. I want to take money away from them to get to that minimum, to that first indifference curve.
Una es la aspiración y otra es la realidad.
Okay, there you go. So I can start with the given level of utility and prices without knowing the income level. The budget line that is tangent to the indifference curve has a property that represents the cheapest amount of expenditure. Right? So the expenditure function is the lowest income, I, such that you can achieve utility level U. I can compute the compensated demand, right? In terms of the expenditure function, where H of X is the consumption of good X, if PX and PY are the prices, and I am constrained to a utility level U. In other words, I want a fixed utility. That has to equal the usual demand for X if prices are PX and PY, and my income is the minimum income that will allow me to achieve the utility level. So instead of having my Hicksian demand, that's H of X, PX, PY, and my utility level, right, I have PX, PY, and my expenditure function, which of course is a function of U. And like I said, it's okay because we assume that U is monotonic. So I can go from my direct utility function to my indirect utility function to my expenditure function. Okay, so this is our demand, or Hicksian demand that achieves a utility level of U, and this is the demand that achieves the highest utility level for a given expenditure, E, right? Where the expenditure is the minimum amount to achieve U, which is fixed. Right? So, having done that, right, I can go ahead and take the partials, right, of h of x with respect to px, and that's going to give me dx over px, plus I have an indirect effect, right? I have a direct effect, px, but I have an indirect effect where px affects expenditures and expenditures affects my Marshallian demand. So I have the two parts. I have the direct effect, and I have the indirect effect of the chain rule, right? I have dx, the partial of dx with respect to I, and I have the partial of E with respect to px. Now, why am I using I here and expenditure here? Because conceptually, right now, they're different. Conceptually. Mathematically, they're really the same, right? But this is the minimum amount that I need to achieve that utility level, and this is just the income I have. So that's just conceptually why I'm writing E and I instead of just I and I or E and E. Right? So now, what I do is I want to solve for my Marshallian demand. So my Marshallian demand will give me my Hicksian demand, or the partial of h of x with respect to p of x, minus d of x over I, or the partial of dx with respect to I, times this partial of e with respect to pi, right? And note, without savings, my expenditures and my income are the same. But I was writing them differently because conceptually they're different. So the first term on the right-hand side is the substitution effect, right? The first part of the second term, dx, or the partial of dx with respect to I, is the one that is positive. We have a normal good, and negative, we have inferior good. The last part, right, the partial of E with respect to px, my expenditures with respect to the price of x, is the additional expenditure needed to keep utility constant. That is, when prices go up, I need more income. When prices go down, I need less income. I'm also claiming that my expenditures, or my partial of expenditures with respect to px, is just x. And if we look at our normal constraint, our normal budget constraint, that's always going to be true, right? Because the change in income with respect to px, right, is always going to be x. So if I take just that, 100 equals 5x plus 3y, right, and I take the derivative with respect to x, I just get 5, which is, I'm sorry, I just get x. I take the derivative with respect to px, I just get x. Said that badly, so now I have to write it. So I have I is equal to dxx plus 3yy. So the partial of I with respect to px is just x, right? And that's basically where the logic comes, but suppose I'm consuming amount X of a good. If the price of the unit of the good increases, in order to consume that same amount X, I need to increase my expenditure, right, by the amount equal to the number of units I was consuming, X times the increase in price. That is, the change in expenditure equals the number of units I was consuming times the increase in price, right? So the change in E equals X times the change in P, right? What I'm claiming is that it's also equal to the amount that I have to be compensated for as a result of the price change. And the mathematical result comes from something called the envelope theorem. But logically, I think it makes sense, and of course, if I do it with just my, excuse me, just my budget constraint, that's what I get. Right? It's how much do I need to be compensated for, right, when the price changes to remain on the same utility level. Right? Suppose originally I consume 5 units of X at a price of $10 per X, so my total expenditure is 50. Now suppose that the price of the good X increases from $10 to $11. So now I need $55. That means I need 5 extra dollars to consume the same amount, right? Therefore, to continue to consume 5 units of good X, right, my expenditure has to increase by $5. The change in expenditure of $5 is obtained by multiplying the change in price, $1, times the change in the number of original units I was consuming, 5, right? There is just the first and second order effects. The first order effect is just the additional expenditure. The second order effect matters only if I'm making large changes. It does not matter if I'm making small changes. Okay. So instead of writing the partial of dx with respect to I, the partial of e with respect to px, I just write negative x, the partial of x with respect to I, after I did it. So I have my Marshallian demand is equal to my Hicksian demand. The partial of dx over px is equal to the partial of hx over px minus x times the partial of x with respect to I, where x, of course, is the partial of e with respect to px. I'm sorry. So, we know that the substitution effect's always negative, right? If the price of an increase in a good, the compensated demand for that good decreases. The demand may increase or decrease, but the compensated demand decreases, right? We also know that X is positive if it's a normal good, negative if it's a inferior good. The derivative with respect to income will be positive if the derivative of the total demand with respect to its own price will be negative. However, if X is an inferior good, the derivative of the total demand with respect to its own price may be negative or positive, depending if it's bigger than the substitution effect. It would seem that if X is an inferior good, there's not much to say about it. However, in recent years, there's been area research that looks in conditions which can say something about the relative sizes of our income and substitution effect. The book gives the example how to compute these terms. It calculates the substitution effect by going through the calculation of the compensated demand function. It's a pain, but an easier way to do it is kind of like we did it graphically, right? That is to calculate the substitution effect, or take money away from and get the substitution effect, get the total effect, and the difference between the two is our income effect. Okay. And that's all I have for today. Next week, we're going to get deeper into the substitution and income effect. So I'm going to leave it here so you guys can think about it, and that way, hopefully next week is not too daunting. Okay. Let me get back to you. I actually made plans for next Wednesday with my boys. I have them next week, and I have plans for next Wednesday. They have activities at school. I'm going to see if maybe I can get out of that. So give me time. I was going to do it. By the way, does anybody have a problem making it on Wednesdays at 6?
Yo prefiero 7, pero es mi voto, pero ustedes voten lo que...
How about 6:30?
Well, I can, some days I can get here at 6, but some days I'll play. People prefer me on 6, I'll be on 6.
Let's make it 6:30. Is that okay? 6:30, can you make it? Okay. If it's a problem, we'll push it back to 7. Does anybody have a problem with coming every Wednesday instead of Wednesday and Saturday every week?
Decisiones, voten, hagan una votación y ya, exacto.
No, o sea, es que estamos esperando con ustedes porque lo discutimos y nadie tenía problema, estábamos esperando a ver si no ustedes tenían.
Ya todos votamos el miércoles.
Así es eso. No sigue nada.
Miércoles a las 7.
Ustedes decidieron, nos ven los miércoles a las 6:30. Con orden de hora.
No,
Estábamos esperando por ustedes.
Entonces, simplemente no puedes llegar a las 6:30 entonces.
¿Qué?
No puedes llegar a las 6:30.
Ah, no, mis razones son bien triviales. Sí, puedo llegar a las 6:30. Porque yo tenía la rutina, jugar venía,
See, the reason I came up with this is because, well, I get my boys every other week. So I can leave, they're older now, I can leave them at home. So I can make it now, but I couldn't make it every Saturday, which is what some people were pushing for originally, to make it Saturday. Now, if we have to, can you guys make it on a Friday? Is there anybody that cannot make it on a Friday?
What hour?
It would be the same, 6:30, it could be
Or
7.
6.
Huh?
Friday is hard. In case we have like a special occasion or something, I mean.
Yeah,
Special circumstances.
you have to make up the class.
Well, if it's something that can be planned, yes, but like every Friday.
Oh, no, it wouldn't be every Friday. I mean, even if it was, I thought about making it every other Friday, but then Wednesday, Thursday, it would be the same thing for people. It would be worse, it wouldn't have that.
But in my opinion, if it cannot be Friday and it's something that we have to do, I prefer Saturday.
Okay. The problem is we have 2 people that simply cannot make it on Saturday. We're gonna-
I didn't know that.
Y si dejamos ya la clase de miércoles a las 6:30
Mm.
y ya. No,
That's probably gonna be the,
And you?
what we're gonna do. I'm hoping for you guys' sake that we can make it next Wednesday. Just let me talk to some people, and then, I will go ahead and send
Y el
it.
sábado está tentativo.
Sábado, hora de tentativa.
Ok.
Si puede resolver para el miércoles, pues el miércoles. Si no puede resolver, el
Para el
sábado.
viernes sabemos aproximadamente, va a ser.
Sure. I should be able to send you an email. So it would be, we meet at 6:30. Okay, so more than likely, I'll see you guys next Wednesday. If not, I will see most of you on Saturday.